Hello, everyone, and welcome to today's live broadcast, Understanding Your Biosafety Cabinet, 3 Approaches to Improving Safety in the Laboratory. I'm Susie Valdez of LabRoots, and I will be your moderator for today's event. Today's educational web seminar is brought to you by LabRoots and sponsored by LabConco. For more information on our sponsor, please visit them at labconco.com. Now let's get started. Before we begin, I want to remind everyone that this event is interactive. We encourage you to participate by submitting as many questions as you want at any time you want during the presentation. To do so, simply type them into the Ask a Question box and click on the Send button. We'll answer as many questions as we have time for at the end of the presentation. If you have any trouble seeing or hearing this presentation, simply click on the Support tab found at the top right of your presentation window or report your problem by clicking on the Ask a Question box located on the far left of your screen. This presentation is educational and thus offers continuing education credits. Please click on the Continuing Education Credits tab located at the top right of your presentation window and follow the process to obtain those credits. I'd like to now introduce our presenter, David Wasesha, a project manager at LabConco Corporation. David, welcome. You may now begin your presentation.
Thanks so much for the introduction, and thanks to everyone who's taking a portion of your day out to learn a little bit more about biosafety cabinets. They're obviously a well-known, important tool in many laboratories, and so today we're going to look at just some basics about some of the biosafety cabinet options and types and when they should be used and taken advantage of. Also, we're going to talk about a couple of ways to look at the types of biosafety cabinets in relation to user safety and features and functions of each of those biosafety cabinets and how users can understand what's happening with their biosafety cabinets better than they may know. We'll also look at some general practices that should be taken with biosafety cabinets on a daily basis, a weekly basis, monthly basis, and a lifetime basis to better prepare you for things that might come up with your biosafety cabinets over their lifetime. So just again, a quick highlight, we'll talk about the different biosafety cabinet types for Class II BSCs with a little bit of background on biosafety in general. Looking at how to interpret some of the things that your biosafety cabinet is telling you. And then also just, again, looking at user responsibility to make sure that biosafety cabinets in your possession are operating correctly and keeping you safe and keeping your work contamination-free. So let's step back a minute and just talk about some of the different uses for biosafety cabinets. Right in the name is self-explanatory. They are really focused on containing and controlling biohazardous material. And biohazardous material can come from many different things. It's a living aerosol or particulate. It could be a virus or a bacteria or another pathogenic life-derived material. And that might mean working with samples that come from animals or humans or even plants. There are a lot of really good resources that go way more in depth into requirements for safe handling of biosafety or biological organisms, especially pathogenic organisms. One of the best for North American-based people, particularly United States-based people, is the CDC's BMBL guide, which talks about laboratory design and specifics for even individual organisms and how to handle them safely. Another great resource for anyone using a biosafety cabinet is the NSF ANSI Standard 49 guideline on biosafety cabinet design. And while the CDC document is free, the NSF standard is paid for, but there is a section of it that's made available to all users called Annex E, which contains a significant amount of information that's free and open to the public, that has great information on how to maintain your BSC, things to look for, how to select one, and is a great resource for anybody who's responsible for biosafety cabinets. You'll also find if you go into the LabConco website, we have lots and lots of good articles and resources to talk about everything from different types of BSCs to should I use a UV light, to what are some applications for my biosafety cabinet that I might not know about and perhaps want to learn more about. So all good resources, definitely recommend accessing them at some point in time during your time working with biosafety cabinets. So one of the other things I just want to hit on real quick, you'll see in some of the slides, are just a mention of biosafety levels. Now, on the slide I mentioned that the designations come from the CDC with respect to the levels and requirements for different types of measures to keep a laboratory safe. These do vary depending on where you might be. So if you're sitting in Canada, certainly you know that there's different guidelines, free and available as well. And depending on your country, you may find the same is true, where if the CDC doesn't apply, there might be another leading document. So good starting point, and certainly a reference for this this presentation is the CDC BMBL. And just to go into that a little bit more clearly, there are 4 key classification levels for biosafety: BSL 1, 2, 3, and 4. As you look at them, the lowest means the least pathogenic or the least risky, up to BSL 4, which would be highly pathogenic, non-curable diseases such as Ebola, for instance. So you'll see those terms used throughout. But in large, the biosafety cabinet, or the BSL level, dictates what kinds of equipment and safety precautions you need to take. So the first approach I want to talk about in improving lab safety by better understanding your biosafety cabinet is to know the classifications and the types of biosafety cabinets that are offered. If you look at all of the biosafety cabinets made in the world across all manufacturers, you'll find a lot of key concepts that are similar between them all. And they're kind of outlined in these 3 different classifications of protection. So paramount to all biosafety cabinets is that they're a ventilated biological containment device, which is simply put, is a containment device that's moving airflow in directions to help keep your work sterile and yourself safe. So we can break those up into 3 categories. The first one is personnel protective airflow. You'll notice the video showing right now is just an image of someone with their hands inside the biosafety cabinet. But if you were to measure airflow on the outside of the cabinet, there's actually airflow coming in towards the biosafety cabinet into the front grill, which draws aerosols away from a user's breathing respiratory area, their body, and keeps them contained. You'll also notice the video that's playing, this is representative of product protection, and it comes in the form of laminar or unidirectional downflow air, which is moving in a straight, consistent velocity and direction to help sweep away contaminants from your work. And it's coming from a HEPA filter, which we'll get into in a second here, but this air is very pure and helps keep cell cultures clean, helps keep sterile drugs clean, and contamination-free from the work that might be adjacent within the biosafety cabinet. Not so visible here, but also an important consideration is the environmental protection offered by a biosafety cabinet. And as you see, there's smoke being generated in this image. It's going down into a channel and then in some cases being directly exhausted to the outside. Some cases recirculated, but before any of this air that is potentially contaminated re-enters the room or an exhaust system, it's going to pass through an exhaust HEPA filter so as to purify the contaminants before moving that air somewhere outside of the biosafety cabinet. So for all of that airflow, there's got to be a driving force, and that's done in a biosafety cabinet using a blower. Over the years, many different technologies have been used. Most prominent and most favorable and common right now is that of an ECM blower or a DC-powered blower. These are similar to what you might find in an extremely high-efficiency furnace or air conditioning system. They essentially run more energy efficient. They're quieter and cooler because they're using less energy. They're also highly reliable with lifetimes in the 10 to 20-year range for biosafety cabinets, which is effectively the life of a typical biosafety cabinet. They also sometimes are outfitted or programmed with a monitoring software that can look at the output from the biosafety cabinets, airflows, and say, am I running exactly where I need to be? If not, they can automatically make changes so that the airflow for inflow and downflow remains within the calibrated range from its initial or yearly certification. There's also an important part of the biosafety cabinet, which is the filtration, which keeps biological hazards from escaping the biosafety cabinet, but also helps to purify air going down into the work surface area so that you can not only protect yourself but work in a sterile environment. And this is a cutaway of a B2 biosafety cabinet, but all Class II models have a supply and exhaust filter to help purify that air before entering critical areas, either the lab or back into the work area. The function of a HEPA filter is pretty basic. It's a high-efficiency particulate air filter. There are many different grades and levels of HEPA filters, but what you'll find in biosafety cabinets is a filter that's typically 99.99% effective against 0.3 micron particles, which means that most biological constituents are much larger than 0.3 microns and will be more effectively trapped by a HEPA filter. We have a couple of great articles on our website if you want to learn more on HEPA filtration, but in this instance, just highlighting the two locations for the filters within a biosafety cabinet. They're made out of glass fibers that are woven and then folded for lots of surface area, and you can see in the supply filter shown here, it's stuck into an aluminum frame. This means that while the frame is very, very durable, the fibers are actually quite fragile. So HEPA filters need to be treated with extreme care when they're either being inserted or pulled out of the biosafety cabinet by a certifier. And also, if you happen to perhaps want to do a deep cleaning on the biosafety cabinet and you remove the diffuser on the inside of the BSC, you need to be extremely careful so as not spray any liquid on the filter or not touch the filter either. Here's just a quick shot of what a HEPA filter looks like, and you can see there's lots and lots of ridges here. That's all of the folds, and what those translate into is a significant amount of surface area for particulates to load, giving a biosafety cabinet an extremely long HEPA filter life. So if we mate all of that together, we end up with a Class II BSC, 2 filters, sterile air for the work environment, and then also protection for a user. But there are different ways that we can move that air through a biosafety cabinet depending on what's used in the biosafety cabinet experimentally, maybe regulatory requirements for exhaust, and you can see those are all represented here in blue and red colors. Now, blue is going to represent, over these next several slides, areas where it's safe to work with microbiological substances, particulates, but not chemicals, because that air is either recirculated back into the room or back into the cabinet, which means that it may be potentially hazardous to have high volumes of chemicals. Chemicals are not trapped by HEPA filters. They are only particulate filters. So if you are working in a biosafety cabinet, just understand that only the particulates will be trapped, but any chemical gases will not be trapped. So the first and probably most common type of biosafety cabinet is what's known as a Class II Type A2 BSC. And chances are, if you've ever worked with a tissue culture hood or a bio cabinet, it's been an A2. And there's a cross-section here showing some of the airflow. These typically have an inflow rate of about 100 feet per minute, typically 105 nominally. And they're approved for all BSL levels per the CDC, with the exception, of course, that if you're handling Ebola, you may need a positive pressure bubble suit. A2 biosafety cabinets, if you look at the cross-section, push some of their air back into the work surface, downflow air, and some out of the biosafety cabinet is exhaust air. Sometimes this is referred to as a 70-30 exhaust recirculation split. That number does vary from every manufacturer and every model, but understand that part of the air is being recirculated. So What that means is if you're working with biological aerosols, particulates, then you are safe. Those will be trapped on the HEPA filters. But if you're handling chemicals in any amount, a portion of those chemicals will be brought back into the work surface area. So you need to be mindful and do a safety risk assessment of the volume of chemicals being used and potentially consider exhausting this BSC with a canopy or moving to a different type of biosafety cabinet. So as a representative of the airflow and the work area where it's safe to work with chemicals, you can see this entire area is blue, which means that it's not a great idea to work with anything more than very minute levels of chemicals within the work surface area. Now, I mentioned the canopy design. That's a transition adaptation for the top of the biosafety cabinet that can connect the biosafety cabinet to a building exhaust. And it's, per NSF 49, it's recommended for radionuclides, minute volumes of volatile chemicals and toxic chemicals as an adjunct to microbiology. So in no sense is a biosafety cabinet first a fume hood and then second a biological hood. It is really designed to be a biological hood first. That duct design looks something like this, and the point of the slide is just to be aware that a biosafety cabinet can tie into building ductwork depending on its style. A2s and C1s have the easiest ability to do that, and they always need to be connected to a remote blower at the distal end of the exhaust, whether that's shared between many BSCs or a single blower per BSC can depend on the building design. But in any installation of a biosafety cabinet that is vented, it always has to have a remote blower typically located on the rooftop. So you might be thinking, well, there are applications where you might need to use more chemicals than just a small, minute, trace amount. And so over 30 years ago now, a style of biosafety cabinet came about. It's classified not as an A, but actually as a type B cabinet. And there are two types. There's a B1 and a B2. The B1 is shown here, and their intent was to provide a total exhaust pathway for chemical safety. B2 is most common, and you can see here in this design, very similar to an A. It's got a minimum of 100 feet per minute inflow velocity. That's the air flowing into the front of the cabinet, keeping you safe. It's safe for different types of BSL work. And it's intended to somewhat marry the merits of a fume hood into a biosafety cabinet by being 100% exhaust, which means that the biosafety cabinet must at all times be ducted to the outside to provide chemical safety. And sometimes that can be costly because you're exhausting quite a bit more air, about twice as much as an A2 when vented. And it can be difficult to maintain because the B2 style biosafety cabinets and B1s for that matter don't have an internal blower that easily maintains a constant volume supplied to the duct. So if your building exhaust has a fluctuation, that will directly impact the B2 and could cause containment issues without having a redundant backup blower. Now, if we look at the work surface area, you can see working in a B2 is a better fit for larger volumes of chemicals. As you can see, this entire area is red, which means that it's suitable for larger volumes of chemicals because no air is being recirculated, and there's no chance for explosive risk for accumulation of chemicals within the work zone. And so if you do have large open containers or mixing large volumes of chemicals, a B2 is a better fit than an A2 when vented. But there are some cons to be aware of when selecting these BSCs that do directly impact not only the energy costs and complexity of the ventilation, but also workplace safety. So you can see that while you do have chemical costs, you do have the added cost of the dedicated exhaust, the operational safety. That's tied to the blower being building controlled, not biosafety cabinet controlled. So fluctuations can impact user safety. And then lots of design and installation and operational costs. And the inflexibility of the B is a key component of their design as well. So if you ever wanted to use the biosafety cabinet without venting and using precious, expensive energy, you simply cannot because the B2 will not start up and it will just be a dead air box that won't provide any personal protection. So there's a different type of biosafety cabinet that can marry the two together. It's known as a Type C1. This is the most recent addition to the NSF standard within the last 5 years. And it is similar in that it has identical inflow requirements, but it's flexible in that it can be a Type A2 style BSC where it recirculates air, or it can operate in a B mode where it has a dedicated 100% exhaust, but doesn't require all of the dedicated duct design or the strong exhaust requirements for a B2 because it's providing constant air volume into the exhaust for a biosafety cabinet. These are easy to duct and connect to a building system. You can have a fume hood on the same exact pathway as this BSC type, whereas a fume hood connected to a B2 would be very difficult to balance. And there are also some strategies with the internal blowers that can help promote and enhance user safety by allowing for stability of the biosafety cabinet's airflow in the event of a building fluctuation. You'll see here the one unique point about the C1 is that it has a keen designated area for 100% exhaust. When in B mode, you'll see that noted by the red highlighted area on the slide. And when this BSC is connected to building exhaust, if you have to work with any volumes of chemicals that are abnormal or larger, work in the center dished area, and it's a well-defined area that helps users understand where they can and cannot work with chemicals safely. So if you were to look at the C1 and its flexibility and safety, so the first point I want to make is that it's a flexible biosafety cabinet that can be used in either A or B mode. So you don't have to make a commitment one way or the other when purchasing a cabinet, and it will always be safe, provided that users understand the application that they're working with and what mode the biosafety cabinet needs to be in. It also saves a lot of energy because it's got airflow exhaust about half of a B2. So lots of green quality to the biosafety cabinet while also maintaining a full protection by having 100% exhausted air. And if you're in an old building or in a complex design, you can use this type of biosafety cabinet to enhance the ability to connect into ventilation without much frustration. If you're familiar with B cabinets, you may have experienced some of their challenges. And because a C and an A both provide constant volume to the ducts, there is less challenge with exhausting them. And it also simplifies the process for selection of a BSC. So if you frequently change usage for your bio cabinet from needing to have chemical protection, or you're evolving your research and you don't know where it's going to lead you, you may end up with a biosafety cabinet that requirement change throughout your work. Well, a C1 is designed to grow and adapt with you. And not in this presentation, but if you'd like, there are a couple of great videos on our website explaining some of the really interesting alarm and safety protection features that C1s offer by running for additional time and keeping the biosafety cabinet operational in the event of a building fluctuation or the building system dying. So enough time to clean up safely and get out of the biosafety cabinet without being contaminated yourself or contaminating others. So just a quick snapshot looking at the biosafety cabinets and their cost performance. So here's an A2, roughly over 15 years. You're looking at about $5,000 to operate and maintain with electricity and service. And if you compare that to in a ducted fashion between an A and a C, the C is nominally more expensive, but offers quite a bit more safety from chemicals and can be flexible with you. More importantly, if you look at a C versus a B, you'll see the costs are quite large for a B2 versus a C1, not to mention the additional requirements of having dedicated ductwork and a large exhaust fan. So it's quite a burden on a building, not including the costs of operation, which may not be a part of the initial purchase consideration. So one other thing I want to talk about is just a common question we ask is when do you need to vent a BSC? Well, ultimately you need to do a risk assessment with your work and what chemicals you're working with. But if you have a A2 these are a couple of the things that are suitable for that type of BSC to be vented. They would be odorous samples, small volumes of chemical solvents, and small concentrations of volatile chemicals as well. So really smaller volumes. If you have larger chemical volumes or something that's particularly carcinogenic and you don't want any recirculation into the work area where your hands are, a C1 or a B2 makes a great fit for exhaust. All right, point 2. Improving your biosafety cabinet knowledge and understanding and safety is not only knowing the types of BSCs and how they function and if your work is correct, but also understanding, after you've made that selection, understanding what your BSC is trying to tell you. Obviously, there are lots of improvements that have happened in the industry to help users become safer users, but there are still a lot of technologies out there that don't clearly represent information. So here's just a fun look into LabConco past, and you'll see 2 iterations of biosafety cabinets here. The first one on the left is several decades old, and the one on the right is about 20, 25 years old. These are both obviously discontinued models, but if we look at their control panels, you'll see some pretty basic information. On the left, you'll see you've got on and off buttons for the blower and the light, and then there's also a small gauge, a magnihelic gauge, or mini-helic gauge as it sometimes is called, and that shows the static pressure buildup of the biosafety cabinet's filters as particulates from work and the environment load. And that is the status indication of the performance of the biosafety cabinet. There's no mention of airflow or filter status, just a gauge, which can be highly variable from filter type, from biosafety cabinet design, et cetera. So while it's important to look at that gauge, it's very difficult to understand what it's telling you. Now on the right, you'll see there's on-off switch for a light and a blower, and then a red dot, and that just tells you that something's wrong with the airflow, but it doesn't really tell you really much of anything about if the airflow is too fast, too slow, is it within range but maybe not perfect. And so these are things that are on biosafety cabinets that are indicators that something is wrong, but may not tell you the full story. So if you have an older biosafety cabinet, please be aware that these are not replacements for, or these are not full communicators for exactly how the biosafety cabinet is performing. You do need to seek out a third-party certification and make sure that it's probably on a more relevant, frequent schedule than the typical 1 year, just to ensure that the biosafety cabinet is operating safely. So where do BSCs land today? Well, if you have a biosafety cabinet that speaks and presents information clearly, it looks something like this. And you'll notice that there's quite a bit more going on than an analog gauge or a beeping light. And so some of the things that you should be aware of that modern BSCs from LabConco include are a filter life gauge to tell you how long your filters last. Now, of course, that gauge is going to last several years, but it's important to know that you're not using a BSC with a completely loaded filter. You'll also see indications for the biosafety cabinet's operation with its blower on or off, where airflow is moving and how fast it's moving to know that it's within calibration. And you'll see here all the LabConco models include a screen right at the eye level. So not only is that information very clear to you, it comes in 8 languages even, but it's right at eye level. So if you block the sash and cause an alert, the display will explain to you how to correct that without you having to go find a manual or lean back and look upwards at the top of the biosafety cabinet for information. So some of the things that are important to know if you're a BSC user or work with people who do use BSCs are the functions that are available beyond the screen. On LabConco models, that might include things like the Smart Start features where the biosafety cabinet can start up and shut down automatically with the raising and lowering of the sash. Also for users to understand if they are going to be using a UV light, how long that UV light is set to run for, information that would be clearly displayed on the screen. Also, it's important to just have an understanding of what filter life and airflow mean. So look at the certification sticker on your biosafety cabinet and look at what the biosafety cabinet is displaying, and make sure that your filter is not completely out of life if you're using the BSC, and make sure that the airflow is matching what the BSC is supposed to be certified at. Our systems will alarm to tell you when the biosafety cabinet is out of range, but it's important still to do that double check and confirmation. Also, you should be aware of some of the alarms that can happen and understand what they mean. Our models include screens like this that tell you what the alarm is and how to correct it. And if you're not familiar with these alerts and alarms, it's strongly recommended to become a little bit more familiar with your BSC so that you can react when you're in the middle of an experiment, potentially with something hazardous. The last thing I'm going to talk about is being a responsible user. So a bit of a dovetail off of the last slides, which is to say that you should be aware of not only how your BSC performs and what type of BSC it is, but how to use it properly. This section may depend on depending on what kind of work you're performing in the biosafety cabinet, but in general, there are a couple of things that all users should be aware of. And the first thing is to make sure that your BSC has a current certification label. Certification is a process that typically happens once every year or sooner, and it's a process done by a third party that checks, they're trained professionals to check the airflow going into the BSC as inflow, the downflow sterile air, and to make sure that the filters don't have any holes in them so that your work is safe, you are safe, and that your filters aren't leaking any biohazardous materials in and out of the BSC. Once you know that certification is present, turn the BSC on and let it sit for a little while to stabilize its airflow and allow for the environment to clean up. And also be aware that you should really assume that a biosafety cabinet may always be contaminated. Certainly if you work with sensitive cell cultures and you've been growing a cell line for some time, the last thing you want to do is to have that line infected. So it's important to just always assume that the biosafety cabinet needs to be disinfected prior to beginning work. One note I want to make that I hit on earlier is on the inside of the BSC, on the ceiling is directly behind the grill is the HEPA filter, that is the supply HEPA filter. If you are going to wipe that grill down, be sure to spray a towel and then wipe. Do not spray the filter because disinfectants and liquids can damage and contaminate supply filters. Okay, so while working, it's important to always treat the BSC as a precious, sterile environment. So anything that you bring into the environment, whether it's yourself, whether it's materials, make sure that you disinfect them prior to entering the BSC. Definitely want to focus on working at least 15 centimeters or 4 to 6 inches inside the biosafety cabinet so as to prevent or limit the risk of bringing bacteria or other contaminants out of the BSC and onto your person or onto the outside of the BSC. The last thing you want to do is self-inoculate while working with hazardous microbiology, and working within the BSC is a physical advantage to keeping that bacteria and other hazardous microbiology inside the biosafety cabinet. You should also plan to work aseptically, and that means working in a single direction. So if you remember the diagram showing sterile downflow air moving in a straight, uniform direction, working aseptically is the same concept, just with user habits. So you can see this diagram where we've got all sorts of our consumables on the left, and you're working in the center and then moving to the right with your waste. And doing this is just a simple process of keeping the environment as contaminant-free as possible, keeping a clean area clean and keeping a dirty area dirty. And of course, if you have open materials, keep them capped. Not only will it help with keeping them contamination-free, but it will also reduce the risk of escape of something from one of those containers or vials or tubes or plates onto your person, onto your other work, and into your, as a health risk to yourself. Also, if you spill, be a good steward of your biosafety cabinet and your work and clean it up immediately. Don't leave it for the next person who might use the BSC. Don't allow it to impact yourself by getting all into your gloves, and definitely don't allow it to impact your work. So just a quick run through of what a spill in a biosafety cabinet might look like. No different than any other spill in the laboratory. Use absorbent cleaning grade materials, so such as an absorbent pad. Dampen with a disinfectant. Try to wipe in a fashion that moves inward so as to contain but not spread what you spill. And definitely, depending on what you're working with and what cleaning you're working with, use a chemical that has a contact time that's suitable to kill your organism. Now, in this diagram, you'll see a bottle of Clorox. That's bleach. Be mindful that bleach is not a good suitable fit for stainless steel, as it will rust it. There are lots of sporicidal and other disinfectants out there that are suitable for almost every microbiological organism that can be used to kill and remove from a spill. Once you're done, treat the waste obviously as hazardous waste. Re-disinfect the surfaces in the area, swap your gloves out, wash your hands, and then resume work. It's imperative to follow these steps to protect yourself and also to protect your work. Once you're done working in a biosafety cabinet, there are also some basic steps that should always be considered, and that includes disinfecting any materials before you bring them out of the BSC, followed by a full disinfection of the BSC work area. And that means cleaning the visible surfaces, cleaning underneath the work surface as needed, and cleaning areas that look like they might be prone to collection of more contamination from your work. It's always a good idea to close the sash once you're done with disinfecting the entire BSC. If you have a UV light, certainly you can use it as a secondary disinfection. It should always come as a secondary disinfection to chemical disinfection. And you may also choose to use a night smart mode, which is a low flow airflow feature on a LabConco BSCs that keeps the environment clean and free of hazards by pushing a small amount of air through the HEPA filter on the supply into the work environment. Just a couple of other quick notes to consider if you're a user that falls into the category of using more than just cell culture materials. So maybe you need a microscope for your work. Consider where that's going into the BSC and if you need some special considerations. So here you'll see a user working with probably non-pathogenic organisms on the open bench, and there are microscopes that are, can also fit into BSCs, but you'll see here there's a problem with this design where the microscope is actually crossing the barrier from the inside of the BSC to the outside, which could potentially impact a user. So if you're a user like this, consider a task fit BSC such as our cell logic models, which integrate a microscope safely through the glass in the sash so as to remove contamination from the BSC out of the containment environment and to make using a microscope more comfortable. Another thing to hit on is maintenance, and this may be one of the lesser thought of components of biosafety cabinets, but it's important to have set schedules for daily, weekly, monthly, and yearly processes. So we talked about checking the certification label. Definitely check the filter life and disinfect, and make sure that if you see an issue with a biosafety cabinet, you report it to the person who is responsible for managing that equipment. Because you're sitting in this webinar learning more about biosafety cabinets, you're armed with extra information to keep yourself safe, but perhaps you work with another person who might not have as much experience and they may not know all of these things. So think of the people you share your equipment with and make sure that they're aware of things that may not be right with the biosafety cabinet. So on a weekly basis, do a deeper clean, certainly inspect and clean under the work surface. I guarantee if it has not been done in a week, you will find at least something down there. And it's always good to just to make sure that there's no Kim wipes or contamination that's down there that could turn into something more significant and impact the BSC or work that takes place in the biosafety cabinet. On a yearly basis or sooner, you definitely want to approach having the biosafety cabinet certified. And you'll see a label like this on every BSC that's certified. This one happens to be from a national certifier. There are lots of different recommendations and companies out there who do fantastic certification jobs. And this will tell you the type of model, the certification stats, and the next time the certification is due. And these are all important stats to be aware of so that you can work on a BSc that you know is current and tested and safe to use. So those are the three concepts, key areas that you can look at and train yourself on and train others on to become more friendly and aware of your biosafety cabinets so that they can improve safety within the laboratory. And so at this point, I want to open it up to questions on any three of the topics or other biosafety cabinet questions that you may have.
And thank you, David, for that informative presentation. And we will now start the live Q&A portion of the webinar. If you have any questions you'd like to ask, please do so now. Just click on that answer a question box located on the far left of your screen. We'll answer as many of your questions as we have time for. So let's like we have some questions already coming in from our audience members. Our first one, David, is, my biosafety cabinet doesn't display filter life. Is there a way to know how long my filters will last? And in the process of building a new lab, I'm sorry?
Let me tackle that first question. It's a great question. So if you have a biosafety cabinet that does not have a display or does not show filter status, it can be very difficult to assess the remaining filter life if there's no digital gauge. Older BSCs typically rely on a mini helic or magnehelic gauge, and while it's an indication that more loading of the filters has taken place, you should be aware that every HEPA filter has a different pressure load and tolerance to it. So if you replace a filter, the next filter you put into it may be fully loaded at a different level than the prior filter. So it's best to keep current certifications every year or sooner with that style of BSc, and be aware that it is only a rough measurement of where that BSc is in terms of its filter life and its fully loaded capacity for those filters.
Great, thank you. And our next question is, our lab has many different protocols that require BSCs. Is our type A suitable for all types of BSc activities?
Another good question. So type A2 BSCs cover a lot of laboratory uses on the microbiology side. The question you need to ask yourself evaluating your protocols is the content of chemicals within those biosafety cabinets and those protocols that are happening in those biosafety cabinets. If you're using a medium to large volume of chemicals, making a solution, maybe you have an open pan of chemicals that's used for a process, those are instances where you really want to look at how much recirculated chemical vapor is occurring, and whether or not that's going to reach an explosive limit or even close to an explosive limit. And if the answer is yes, there is a risk for high concentration of chemicals, then you probably want to look at a type C1 BSC that can be an A or B depending on use. Or if you always have a large volume of chemicals and you can facilitate the installation of a B2, that may also be a costly but potential option.
Thank you. Our next question is, my BSc hasn't been certified in a long time. Who do I contact for this service, and how much will it cost?
So certification in North America is done by third-party groups, and so the first thing you should do is stop using that BSc. And if you don't have a existing company that provides certification to your university or company, then you can probably do a quick Google search. But more effectively, just give LabConco a call, and we can link you up with some certification options in your area. Now, once you identify that person, certification is a fairly inexpensive cost, typically, depending on where you are, somewhere between $100 to $200.
Thank you for that. And I want to thank our audience members again for their great questions coming in. David, since there is a glass shield, is there any need or requirement for the clinical laboratory technologist to wear eye protection while performing work in a BSC?
So I'll start off with saying that more PPE is almost never a bad thing, but you need to do a risk assessment of what's happening in the biosafety cabinet with respect to how things are being handled, if there's a risk for aerosolization, in which you should also obviously consider a respiration protection measurement. I would also strongly urge looking at the CDC's guide for bacteria and viruses and other pathogens, as they very specifically, explicitly discuss the types of PPE recommendations per type of organism. So if you look and find something you know is going to be an aerosolization risk, almost always it's obviously going to have respiration and eye protection.
Thank you very much. And David, what is the solution to strong stool odor that comes from a stool specimen inside a BSC too?
So stool samples are not at risk of being reaching an explosive limit. They just have a noxious odor that can be unpleasant. And so typically a type A2 BSC would be recommended. To handle that odor, you can either choose to canopy vent the BSC to the outside, or you might choose to explore using a trace odor filter with carbon filtration in it, though you may need to evaluate the cost of how often the stool samples are being used and whether or not frequent replacement of a carbon filter is economical versus the cost of venting a biosafety cabinet.
Thank you for that. And here's another great question. Is it allowed to disinfect with H2O2 dust?
So H2O2 or hydrogen peroxide is a suitable disinfectant. It is typically actually used to decontaminate an entire biosafety cabinet. So a certifier, if they have to replace a filter or a blower, will use a couple of different methods: formaldehyde, chlorine dioxide, or hydrogen peroxide gas, and it's an effective sterilant when used properly. So yes, it is suitable and acceptable to use within a BSC.
Thank you for that. And the number of users, David, is it safe to have 2 users using BSC at one time?
It's certainly not recommended. You have to consider multiple things. One, the size of the BSC, especially if you were to put 2 users crowded together, will impact and restrict a lot of the free-flowing air, both downflow air and inflow air. But to the person asking this question, I also urge you to consider the impacts that 2 users may have on each other, moving their hands back and forth and potentially cross-contaminating each other's work. So when possible, it's always strongly recommended to work as 1 user per biosafety cabinet, especially if you are working with known biohazards.
Thank you for that. And I want to thank our audience again. These are great questions coming in. It always makes a great live presentation. When is it necessary to use a ULPA filter?
So an ULPA filter, or ultra-low particulate air filter, is a similar and near identical construction to a HEPA filter. They use borosilicate glass fibers, and they're typically just more densely woven borosilicate fibers. So their rating is more effective at smaller particulates, but in actuality, at least let me speak first to biologicals. If you're working with biologicals, almost all of them are much larger than the 0.3 micron most penetrating particle size. So ULPA filter rarely does anything but only clog and require more frequent changing when just strictly handling biologicals and other similar particulates. The ULPA filters do have some uses in instances where perhaps you're looking for a nanotechnology application. But what's not different about them is their ability to capture materials or particulates that are smaller than 0.3 microns. So if you look at a HEPA filter, the larger a particle is versus 0.3 microns, the more effective that HEPA filter will trap it. But as you get smaller than 0.3 microns, the HEPA filter is also equally effective at trapping small particulates because they flutter around as they go through the filter. So if you look at recommendations for trapping things that would be handled in a biosafety cabinet, a HEPA filter is entirely suitable for just about every single application, and most certainly for all biological applications. An ULPA filter will only cost more, and more importantly, it will load faster and require more frequent decontaminations and HEPA filter replacements with little to no value for a user.
And speaking of filters, one audience member wants to know, why does a HEPA filter have an expiration date?
So great question. HEPA filters have a very long lifetime, especially when treated nicely. They're made out of borosilicate, inert glass as a media. But they contain a gasket on them that is required to seal that entire filter frame to whatever the application might be, whether it's in a clean room sealing or a biosafety cabinet's internal airflow plenum. And by having that gasket on there, it is the failure point for a HEPA filter. So the stated filter life from a manufacturer may be X date. It does vary by manufacturer, which is why it's important to evaluate and have frequent certifications on your BSC, because that certification process will directly look at the HEPA filter and whether or not a leak has generated, whether through the media of the filter, the glass fibers, or through the gasket itself.
Thank you. And is the UV light an effective decontaminant?
It depends. A heavily debated question in the U.S. The CDC would tell you that they don't recommend using the UV light. The reality is that the answer is a gray area. You first have to evaluate if what you're working with is effectively killed or removed, or not removed, but killed off by UV light. So some bacteria certainly will be more susceptible to UV light than others. So, for instance, like tuberculosis, which has a waxy cell wall, it's very resistant to UV light. And but in short, it certainly is not necessarily a bad thing. It's an extra thing to maintain, but it should always be used as a secondary disinfection measure after chemical disinfection with a suitable disinfection solution.
Thank you for that. And similarly, another audience member says, I am a BMET. Is there any special steps to replace the UV or working light, and do I need to perform a decontamination process?
So the UV light on a biosafety cabinet from LabConco is located in the work zone, so it is in the contaminated space. So prior to doing any work, you want to first make sure that the inside of the biosafety cabinet is disinfected fully, and that means wiping down all the surfaces, including the UV light. To change that bulb, the process is fairly simple on our BSCs. It's just unplugging the power and then removing the bulb and replacing the bulb and then resetting the UV timer. That's an important step because the UV light has a known lifetime. It's typically about 6,000 hours, and LabConco units include a countdown timer to alert users when the UV light is no longer as potent or effective as it once was. But the process is very simple.
And David, how long should one use the UV light?
Again, it depends heavily on the organism that's being used. You can set it to run for a very short duration of time, or you can run it for an unlimited period of time. It just depends on the virus or bacteria that you're looking at. And there are lots of different papers out there for many different bacteria and viruses and other pathogens or contaminants in a BSC. So my recommendation is to do some reading on that and decide if the UV light is an effective decontamination platform for those organisms. And certainly, again, just to reiterate that chemical disinfection should be used as a primary disinfection source first.
Thank you again, David. And I just want to remind audience members that any questions not answered today will be answered via email. We have time for a couple more questions, David. Is there a Magnehelic gauge reading that will indicate that the BSC is out of specification? Example, a 10% of the certified reading.
Unfortunately, the answer is no. So the magnehelic gauge on all BSCs, whether 30 years ago or today, there's some still use them. All it is reading is the pressure differential on the blower or the HEPA filters to show you how loaded those filters are. But that number, that pressure increases as the filters load, and so to combat that, the drop in airflow that occurs as a result, you can adjust the blower upward, but the value doesn't have any way to tell you what the airflow is in the BSC. There may be a separate, depending on the model of BSC, there may be a separate airflow monitor or sensor of something or something else checking that and alerting a user, but there's really no easy way to extrapolate what the magnehelic gauge is telling you, other than the filters are loading and have loaded more than they were previously.
And should the BSCs be checked with the actual equipment that is usually in the hood? It seems we are told to empty the hood before certification.
Yeah. So biosafety cabinets, when they're designed and tested by NSF and ourselves and others, are manufactured and tested with no equipment inside of them. That is how most certifiers test them. If you have a particularly bulky material or perhaps a microscope, you can certainly go back and have that certifier test that BSC with that equipment in there, which will help you get a better understanding of what's happening when that equipment is loaded. I'm familiar with the concept of certifiers asking for everything to be pulled out. If you have a large piece, a box, something large in there, there's certainly nothing wrong with having them evaluate that piece of equipment inside the BSC to get a better understanding of what the biosafety cabinet is doing. Now, I would extend that comment to large pieces of equipment or really dedicated pieces of equipment. But if you have pipette tip boxes or a pipette rack in there, those, they can move around so commonly and easily that it's kind of difficult to get a good assessment from a certifier with stuff that might move around. So just take a look at what's in your BSC and evaluate and have a discussion with your certifier. They're very experienced and trained individuals who can give you a lot of information and insight on what you might experience or how you might even better place the piece of equipment within your BSC to limit cross-contamination and promote personnel protection.
David, thank you so much. And we have time for one more question. Once we finish our work with BSC, do you recommend leaving it on for a few minutes after cleaning?
Definitely, yes. There is no harm in letting a biosafety cabinet run for additional time. If I didn't have that bullet point in there, I will add it immediately after, just to be clear. But definitely, the more time you give the biosafety cabinet to sit in a state before you start using it and after you stop using it, the more likely it's going to clean up any residual particulates and contaminants within that space.
Thank you so much, David. And do you have any final comments for our audience members today?
I just want to say thanks for everyone for your participation. I saw there are a lot of questions that came in. Some we were able to answer, a lot more that I will respond to individually. If you have additional questions that come up, certainly feel free to reach out. My information, I think, is attached to this presentation, or call and contact LabConco directly. We have lots of people in the office who are experienced with biosafety cabinets and specific applications that can help walk through tailored questions to your lab, your environment, your BSC types, no matter the type of biosafety cabinet. So just want to reiterate that we're here as a resource for you to make sure you're operating within your BSCs safely and keeping everyone safe who might touch them. So otherwise, thank you so much for everyone for listening, and I'll look forward to seeing you all on a future webinar, hopefully.
Absolutely, and thank you again, David, and thank you for your important research. Before we go, I want to thank the audience for joining us today and for their interesting questions. Questions we did not have time to answer today or those submitted during the on-demand period will be addressed from the speaker via contact information you provided at the time of registration. I'd also like to thank LabRoots and our sponsor, LabConco, for underwriting today's educational webcast. This webcast can be viewed on demand, and LabRoots will alert you via email when it's available for replay. We encourage you to share this email with your colleagues who may have missed today's live event. Until next time, bye-bye for now.